let's say you're testing a mathematical function and you're a practicing professional in financial markets, let's just say. Oh my gosh, please do not do that because you will lose everything. And see my shirt, see how nice, fashionable. So you know who I am. Right? It's good to meet up again. Okay. Here's what I want to say. That last time what we did was we tested a math function, and we came out with an error output. So we got which would have been, fractionally speaking, it would have been a dollar and 3/8. So we had a whole number and 3/8. But you notice that the decimal, that the fraction is 1.38, which means that you're able to get half a penny by buying the call. What happened was, by buying, just by buying into the air. What happened was that the markets were getting pushed down. So you're, as a market maker, you would want to push the markets down because right now your test models do not function because you know it's an error. And so you're getting an error in the actual pricing, in the actual function itself. And so you notice an error, you buy into it, you call it an arbitrage or whatever, and you're trying to push the markets downwards because you know that it's 1 3/8 and that you're showing 138 or higher, which is a little bit more than 1 3/8. So the difference is actually half a penny because it's 37.5 cents. So you're making the difference up, and you're pushing the markets down, and you're pegging it at the actual price, which is 37.5. So I mean, just to take a look at if this was possible, uh, it's theoretical. If it's possible in actuality, I'd have to get back to you. I'd have to get back to you on that. Um, I'm not a market professional. I'm not a mathematician. All I know is that at some point, at this point, your mathematical models no longer function. The first time, what you did was you bought into it and you arbitraged it for half a penny, and you paid to settle the markets at half a penny lower than what you purchased the call at, or whatever it was. And so that's the whole theory of arbitrage. This time, because we're not actually arbitraging or theorizing anything, all we're saying is that there was an arbitrage opportunity due to an error in the main function, which is the function of the pricing itself. And the function of a function no longer is the same. To say that all mathematical functions now are invalid is probably would be a little bit too nerdy. So So now you can say that you have to either revise your function, and so you're testing that. So instead of buying into the arbitrage opportunity, what you do is you price in as though it were 3/8. What's happening now is that because you're not buying or selling, the the fee is going down. So the fee is going, or the the price itself to obtain the call is going down. So now, you have the the price is going down. So the markets may just go down. There's a good probability that the markets go down because everybody's mathematical model is no longer working. If you think it still works, you might be more insane than me. Okay, so the function is that price is producing an error, and a lot of these arbitragists or professionals know that their mathematical models don't work, and now the fee is going down as well because the market professionals themselves are not buying this arbitrage opportunity for whatever reason. This time, we're just not going to buy into it because we know that there's an error, whatever. Okay, so what happens is that there's a tendency for the expectations to go down. So the expectations of price goes down, the cost goes down, and the probability of the market price is, it could go up or down. It doesn't necessarily change. It could be expected to go down. So the probability might increase of a downturn in the price. But that's not to say that the market would do anything other than stay it's the same price. The fee is going down. Your tendency is going to be, as a professional, is going to be to sell, but you're not buying into the arbitrage opportunity. So now we're basically singularly we're designating this as a arbitrage opportunity. What happened last time was that we pegged the market slightly lower and paid the price in time. Now that we know that this arbitrage opportunity exists at t plus 2, we or t minus 2, I should say t minus 2. We know that we didn't fix the model, like we didn't fix anything. So like now we want to do the same thing. We want to buy the arbitrage opportunity and let them pay for the markets to stay pegged as to where they're at, because nobody's done anything. It's just an error of the main function. But this time we know that we didn't fix anything, and we're riding the bus for more than t minus 2, t plus 2. So it's like I'm thinking to myself, I want to do the opposite of what I did last time to test to see if in fact my model still works, because I'm God according to my mathematical models. And that means that I'm always going to have an arbitrage opportunity, but not based on this because I know it's an error. So I'm not going to buy it. I bought it last time because I thought it was God. This time I'm not buying it because I am. And so that whole function means that the fee is going to go down because everyone else is going to think they're God if they buy it, but they're going to go down. And the probability of the stocks going down is higher too, because a lot of mathematical models are going to be wrong too. So it's just a matter of knowing that all of the liquidating models and all of this stuff like that is going to be a premium. Is going to be a premium for the carry, and so now what I'm experiencing now is that, I mean, I'm not a market professional, so I don't know, but I have less of a cost of carry and a greater probability that the markets go down. So now I'm just going to say that let the markets go down and not do anything and see what happens. So now I'm not paying anything, but nothing happens. Nothing happens because it was just a singular error. So anything that has to do with the market activity could be due to other mathematical models being dialed in or out. So you might have an increase in volatility. You might have an increase in the volatility of the price, but you don't necessarily have a fix in the model. You don't. I don't. You might. I don't. You might have a fix in the model. I don't have a fix in the model. So I know this. And if you do, and you buy into the arbitrage opportunity, you may just become God, because that means that you're going to pay the markets just to settle down or to settle up. No, settle down. And that was just it. That was just the arbitrage opportunity. But now the question is, the probability is that because you thought that your mathematical models still work because you thought you were God, you forgot that there's an error in the main function. So we don't know what's going to happen. We know that you think you know that your mathematical models function, but that was a random. No, it wasn't random. It was a remainder error output. There was a remainder error output in the fractional price that you noticed that there was an error. That's the only way you know this. That's the only way you know it. And so that's how market professionals get down with the math with their calculators, is that that there's a discrepancy in the price, and it's obvious at this point, whether it's a remainder error or not. It's just obvious. So that there is an error in the pricing function, the main function, if you would. But you don't know if you need to fix your models or not. And anybody who thinks that their model works doesn't necessarily know that there is a problem or error with the main function. And part of their job wouldn't be to profit or arbitrage, but to know this. And part of their job would be to keep the prices solvent, or keep the activity solvent. So what happens is the premiums go down, or they can go up depending on which you bought into. So in this case, we didn't buy into the arbitrage opportunity, which proved to be half a penny too great. So that means that that efficient market professionals will not peg the markets slightly lower because we're not buying into there being an error. But there was an error, and the last time this happened, market professionals pegged the markets lower to obtain the arbitrage. They paid for the arbitrage at half a penny profit. So what we have to do this time is not wait and see, but is to know that this price is an erroneous price, but it could change. So what we do is we wait and see, yeah, but we see we're actually looking at a different axis. We're actually looking at the y-axis where the prices are at. As a function of time, prices will show a definite error. During these intervals. So I don't know what time the price showed up because I wasn't practicing as a market professional or whatever, because that's not even top 10 on careers list. Okay. So the time that happened, that occurred, was actually T-2. So we know this. So anytime we see that there's an error, we know that it occurred 2 seconds ago. So that's one way you can possibly look at it if you want to get it in. You take a look at the latency in the volume of price action. So now we're looking at a totally different, we're looking at a volume price graph. So when we see that the volume goes up, we're assuming that nobody has bought into the arbitrage opportunity. So now we can say there that it's taking an agnostic position. But then again, we have to look at 2 seconds beforehand, or whatever the latency might be. 2 seconds before, there proved to be significant activity that we can say statistically was significant, based on who we're actually even tangoing. If it's liquid suppliers, liquidators. So we saw the significant activity at T-2. So we revert to the fact that, okay, so now their activity is to revert back to that. They in fact bought into the arbitrage opportunity. So we see this happen in intervals, and we can only guess at some point, because at the end of the day, we also realize that a great percentage of the mathematical models that are being used are no longer relevant. That was a function that was an error in the main function. So do you revise the model? Now you're just doing what you were going to do because you didn't revise the model. So that's something that's just riding in the back of your head. So now you're watching what you want to see is the the arbitrage opportunity. But this only happens once a day. So what I'm saying is the t variable is continuous. So t minus 2 is, I don't know if it is relevant. I can't remember. But that whole thing has to do with the continuous variable, because we're looking at the simulation, a simulated effect. So t minus 2 might be 2 seconds earlier, or it might be 2 days earlier. It it could be that we're disintegrating the function altogether and making it discrete. So in this case, I'm not sure exactly what the function might be, but the point is that we no longer assume that there is an error. And so if we're no longer assuming that there is an error, we're not necessarily watching an arbitrage opportunity, and we see that the markets have a tendency to go down if in fact there was an arbitrage opportunity. But then again, there's also probability expectations for the markets to go down agnostically, minus just the main function. Okay, so something of a primer on the looking at it from a remainder error, because notice that you notice this at a whole price in 3/8, but you saw that the price was showing a whole number 38 hundredths. So if you had $2.38 flash up, and it was meant to be $2.37.5, let's just say, then you have half a cent that you're arbitraging. But the point is that you know that it's an erroneous price. This way we know it because it's a remainder error. And you happen to be an expert at remainder errors because you're a market professional. the one thing that we do need to understand is how we're able to perceive our models after we know that there was an error in the main function, which was the pricing. So this is absolutely godlike math, because you're pricing a derivative in this instance, and the only way that they price derivatives is through a pricing function. So you're really playing God by arbitraging the markets, because what you're doing is you're actually having to pay to borrow money and take up space in by selling a bunch, because what you did was you bought a bunch and now, or you sold a bunch, and now what you're doing is you're driving the price down so that you can liquidate your position. So it's very godlike math, because your function had priced in the 3/8, but you know for a fact that it was something different, that it was going to be 37.5. So what you have is a remainder error that is worth about half a cent in arbitrage. But if you know and you don't revise your function, then the next time it's going to be a lot longer to arbitrage this opportunity, because you're still testing to see if you need to revise your model or not, because you know that it was an error in the main function. The question is, has it been resolved? Because that's what everybody is doing as efficient market professionals, is driving the price towards efficiency, and the activity should be towards efficiency. So what you want to see is, actually, because we tested this already, okay, what you actually want to see is that when the price flashes, all right, when the price flashes, the remainder error flashes, you want to see an even keel of volume activity. And in fact, you want to see greater volume before it tapers off, because you know that the only people who have revised their models, who think they're, like God, are the ones that are arbitraging. And you know that the expectations for the market is to go down. But the last time this happened, they paid for the markets to stay flat. So this volume activity is what's going to be the indicator as to whether or not they have arbitraged this opportunity or not. Because if they have, that means we have a recurring error. That means that we have an error in the main function, and that we don't need to revise our models. But the point is that we're actually pointing to somebody else. We're actually looking at their models by doing this, because we're looking at the volume at the time that the price flashes. And at this point, the volume should be tapering down rather than tapering up, unless we missed something and we're showing that we're actually able to arbitrage and something a little less than 3/8. So if we're doing that, that means that the volume would still have to taper off. So that's part of that's part of the deal. So that we're not revising our models because we're pointing to other market participants and looking in the volume. We notice that uh, liquidity suppliers are are tapering off their volume activity. So that means that they did not perform arbitrage, and so that means that we do need to revise our models. So that's just how you test into a function of a function by looking at the main function, which is the derivatives pricing model, options pricing model in this case. Which is already understood to be a a model for pricing that is just simply attributed rather than actual. So this might happen frequently. That's all I have to say about that. So if you notice that the volume was actually going down, then you would say that either you're getting what you're having to do, if I didn't mention this, is you're having to look at the latency of the volume as well. So by looking at the latency of the volume, you're able to see if it is in fact the same type of liquidity supplier, and if it is in fact the culprit, the very culprit that you're saying, it's like, well, they're an arbitrager, then the latency is what you're looking for, and taking a look at the part and parcel of the volume itself. But your latency is from the main function is what matters the most. So we determined that our models will find the error. Will find the error at a certain latency. And so that means that the price itself might flash sooner than when we get the volume activity. So if that happens, we may say that we found arbitragers, that it has occurred and that we don't need to revise our models because this is a recurring error. And it will happen in certain intervals, so we know that it's occurring, so that we can perform arbitrage next time in continuous. And what is a continuous time? Continuous time, and be able to derive at a point where we can say, yes, we can definitely apply this math, and we found a probability to when these errors will occur based on the price itself.